And the title of our presentation is Using SigmaXL and DMAIC, Define, Measure, Analyze, Improve Control to Improve Customer Satisfaction. So it's a case study, and what we're going to do is walk you through the various tools. Obviously in a short period of time, it's going to be brief, but just to get a good feel for how SigmaXL can be used in a process improvement project. We'll begin with an introduction to the customer data that is being used here. Has the first row is the column header, followed immediately by data. So you have here customer record number, date, customer type, product type, and so on. One of the things that's important in SigmaXL in the data format is that you have to be consistent. If it's date information, then it's an entire column of dates. If it's numeric, then the entire column is numeric. And if it's text, then the entire column is text. So while Excel doesn't have that limitation, SigmaXL does require that for your analysis. And that's pretty much the way all major statistical products work, that you need to be consistent in your data format column-wise. It's also important that the top row be a single row. Multiple rows will cause problems. You need to have a single row uniquely identifying each column as a column header. Just to quickly go through this, we have customer type, we have product type, we have size of the customer, small, large. We've tracked major complaint, average number of orders per month, average days order to delivery time, and overall satisfaction is actually the primary Y metric of interest. That's what we're trying to understand, the relationship between overall satisfaction and the various X factors. We also, these are survey results on a scale of 1 to 5, where 5 is extremely satisfied and a 1 is very dissatisfied. These are non-integer values. There was some averaging that went into these numbers. The loyalty scores are also from a survey on a scale of 1 to 5, which is likelihood to recommend to others, which is also a very important Y metric. The one that we're analyzing here is going to be overall satisfaction, but questions like likelihood to recommend are very important on surveys. We've also tracked some additional questions along the lines of how responsive were we to calls, rate our ease of communications, and rate our staff knowledge. So this is the data that we'll be working with for this webinar. I am working with the most current version of SigmaXL, version 6, and so just a quick introduction to some of the, or a quick overview of some of the new things. For example, in templates and calculators, the templates are all grouped according to functions. So we have the project, DMAIC, and DFSS templates. We're not going to cover these in this particular introduction, but just to highlight, there are lean tools such as the tact time calculator, value stream mapping, basic graphical templates, basic statistical templates, probability distribution calculators, measurement systems analysis, process capability templates, design of experiments, and control charts. These are all basic templates for quick and easy calculations to get in there, and they're quite popular because a lot of it just requires a simple entry of data, summary information, and you get your results. The other tools in SigmaXL require raw data, such as the Pareto Charts and the Histograms and so forth, and that's what we're going to use the customer data for. So I'd like to begin with one of the common tools that's used early on in a DMAIC project is the Pareto chart, and I'm just going to do a basic Pareto chart of customer complaints, and excuse me. So come down to major complaint, and I'll select that as my Pareto category, and then I'll just click Next. And here I have my Pareto chart showing return calls as being the #1 complaint, followed by difficult to order. Okay, and then I can just finish up on that. There are a few settings that we can modify here, but just for a quick view of the Pareto chart. We also have advanced Pareto in SigmaXL under graphical tools. Advanced Pareto charts allow you to slice and dice. So here if I take, let's say, major complaint, but I group it by customer type, I can see if the different customer types are complaining about different things. And here I have customer type 1, return calls is predominant. Customer type 2, same thing. And customer type 3, same thing. So in this case, stratifying by customer type, I don't really see any significant difference in the distribution of complaints. But this is helpful. Return calls and difficult to order stand out here as being major complaints that we're getting in our feedback from our customers. So the Pareto chart is a very basic tool. SigmaXL helps you to quickly crank these charts out. Now, I'm not going to go into all the details, but you can really stratify. You can include other group category variables to slice and dice your data even further. Now, the other tool that I want to show, this is for discrete data, of course. Pareto charts are for count data, discrete data. Now, if you're looking at continuous data, like cycle time, where you can have, a day and a half, or in our case, customer satisfaction on a scale of 1 to 5, 3.5 has meaning, midpoint has meaning, so we're going to treat that as continuous data. We're going to look at the overall satisfaction on a histogram. And so I'll go to SigmaXL, go to graphical tools, and we'll do histograms and descriptive statistics. So that'll give us not only the histogram, but also the descriptive statistics. And we'll go ahead and look at that. And looking at this histogram, I can see that, well, it's definitely not normally distributed. It's kind of a skew left. You've got a long tail, which is, by the way, a good thing when you're dealing with customer satisfaction, because you want more 4s and 5s and fewer 3s, 2s, and 1s. We have overall satisfaction with a mean score of 3.8 and a standard deviation of 0.8. And then so we have the various statistics. The other thing that we confirm down here is with the Anderson-Darling normality test, that p-value of 0.03 tells us that this data is not normally distributed. So a p-value of less than 0.05 for the Anderson-Darling test tells you that you have non-normal data. So, all right, so this is just kind of descriptive. It's telling us what we have, what the shape of the data looks like, what the average is. I can also slice and dice. So if I hit, I'm going to do again recall SigmaXL dialog, and this time I'm going to stratify by customer type and look at overall satisfaction, but this time broken out by customer type. And in this case, I look at customer type 1 versus customer type 2 versus customer type 3, and here we actually do see a difference. This is interesting because customer types 1 and 3 have nice normally distributed data, whereas customer type 2 has non-normal data, but customer type 2 is doing better because they're getting more of those higher scoring SAT scores, which is really what we want. So again, for histograms and descriptive statistics, you can stratify, you can include grouping variables, and that allows you to nicely slice and dice your continuous data. Another thing that we want to do with this is to kind of get a baseline in the measure phase of what is our performance against some critical customer requirement or some reference value. And what we're going to do is we're going to run a process capability analysis. So we're going to go in process capability. We'll do histograms and process capability. And what we're going to do is we're going to, again, specify overall satisfaction as the Y variable of interest. And the upper spec limit, in this case, actually I don't have an upper spec limit because obviously I want satisfaction to be as high as possible. I'm really only going to put in a lower spec limit. And what I'm going to say is anything less than 3.5 on a survey score is considered a defect. So by putting that in, any stat scores below 3.5 would be considered a quote-unquote defect, and anything above would be considered an acceptable level of satisfaction. And this allows us then to get things like sigma levels and process capability indices and so forth. So I'm going to click OK. And here we have the visual on the overall assessment. We can see that, yeah, we're doing okay. We have a lot of the stat scores above that 3.5 number. However, we have quite a few that are below. In fact, the total below is 33%. So that's really an unacceptable level of performance. And just a comment, the expected performance versus the actual performance. The expected is the theoretical based on normal distribution theory. So if the data is normally distributed, then you can use the expected overall performance. However, as we saw earlier, there's a problem with this data in that it actually is not normally distributed. And one of the things that we should do here is really run this analysis again, but this time using the tool for non-normal data, which is just introduced in version 6. So I'm going to run the process capability for non-normal data. So again, process capability. I didn't show you the capability combination report for individuals, but let's just go straight into the non-normal capability combination report. This is for individuals non-normal. Now, we have a lot of options here, and I'm not going to get into all the details, the technical details. There's the Box-Cox transformation, the Johnson transformation, and for a lot of people, this is pretty complicated stuff. So one of the things that we've done is included something called automatic best fit. And that's what I'm going to run. I'm just going to put it on automatic best fit. I need to put in that lower spec limit of 3.5. And we'll, just to speed it up, I'm actually going to turn off the control charts for now. And so we're going to rerun this now. And it does take some time because it's crunching through about 20 different distributions plus the various transformations to see which of all of these is the best fit. And it's going to come back with a process capability report that adjusts for the non-normality. So we'll just wait. Like I said, the one thing about this is that it does take some time because we're going through quite a few transformations. So I'm going to make this a little bit smaller so that it can be easily seen on the screen. And it shows a beta distribution. And as you can see, the beta distribution definitely follows the data much better than the normal curve did. Plus we have the probability plot showing a fairly straight line. So on the probability plot, had we seen the normal probability plot, that would have shown up not as a straight line, but with the beta distribution, it's roughly a straight line. Now we have expected performance and actual performance very close to each other, and the various process capability indices are given here as well. There is also very important is how well did this transformation or this distribution work. And you have an Anderson-Darling score, but you also have a p-value. And with a p-value of 0.7, that's very good. That's basically saying, you know, a high p-value corresponds to a good fit. A low Anderson-Darling score and a high p-value is a good thing for a fit. Whereas the original data, you see that 0.03 showing that the overall stat is not normally distributed. So I just wanted to quickly show this in the context of establishing baseline. When you have non-normal data, this is a fairly complex topic, but we've really made it easy with the automatic best fit routine. And then you just come down here and you have a look at the, you know, at the score and see is that fit a good fit. There was another tool which I won't run, but just mention in the process capability, under non-normal, there's something called distribution fitting, and distribution fitting generates a report for each possible distribution and transformation. So back to the final report. Obviously, we're still doing poorly. So after all of this, torturing the data until it confesses, we still are left with the situation that we have an unacceptable number of unsatisfied customers. So what do we do about that? Well, this is where now, moving on from the measure phase, getting into the analyze phase, you want to start slicing and dicing and really trying to understand what's driving the variability in customer satisfaction. One of the tools that is very nice for this with continuous data, with a continuous y and a discrete x, is the Boxplot. And so I'm going to run graphical tools, and we'll look at Boxplots. And I'm going to look at overall satisfaction by customer type. And of course, you can stratify by other variables as well, but we'll just have a look at that one. And here we see something that we saw on the histograms with customer type 2 doing better, having a higher SAT score. Just by way of reminder, the top of the box is the 75th percentile. The bottom of the box is the 25th percentile. The middle line is the median, and the dashed line is the mean. There is an option, by the way, with Boxplots that you can turn a legend on, and it explains the various parts of the Boxplot. This is a potential outlier. An outlier is a point that is different from the rest of the data within a group, and that's something that's always of interest. You always want to have a closer look at what's driving an outlier. You know, why? If I have an outlier, that's something that should be looked at more closely. DuPont invented Kevlar as the result of investigating a statistical outlier. So outliers aren't necessarily a bad thing. They can be a good thing, leading you to new knowledge and new understanding. In this case, just looking at the box plot, we do see a difference across customer type. So now, okay, customer type 2 seems to have more satisfied customers, but it still doesn't answer the question why. But it does appear that there's a difference. Now, another graphical tool closely linked to the box plot is the Multi-Vari chart. In fact, I like calling it the Multi-Vari chart. I refer to as a box plot on steroids. So I'm going to run the Multi-Vari chart, and I'm going to actually do a little more analysis than I did with the box plot. So I'm going to do Multi-Vari chart, and we'll do overall satisfaction by customer type, let's say by product type, and by size of customer. So I'm really slicing and dicing this data. And the Multi-Vari tool can accommodate up to 3 grouping variables. And it's a little difficult to interpret at first if you're not familiar with multi-vari charts. The vertical the vertical axis is the overall satisfaction. This is the minimum of the point of the data. This is the maximum. And the blue points correspond to the individual values. Again, clearly we see customer type 2 with a higher level of satisfaction. In this case, for this combination, not only is there a higher level of satisfaction, but there's less variability. So for customer type 2, product A, large customer, we're doing particularly well. And that's something that you would want to investigate and to understand. Perhaps these people have policies and procedures in place where they'll return phone calls within a half a day. Or they've made the process easy for the customers to place orders and address those items on the Pareto chart. But again, with the multi-vari tool, you can scroll across, and there's just a lot of information being presented here. So again, this is for continuous Y data and discrete X data. That's the multi-vari tool. Now, one of the things that is important when you're analyzing graphically, you can get clues, but you really need to use hypothesis testing to validate your graphical analysis. And the tool that we're going to look at initially is ANOVA, Analysis of Variance. And I'm going to look at overall satisfaction by customer type. So SigmaXL, statistical tools, and I'll come down to one-way ANOVA, that's one-way analysis of variance. And I'm going to select overall satisfaction by customer type, and we'll run that. And again, as with any statistical tool, there's a lot of information here. Actually, I'll start with the graph, because the graph at the bottom is very similar to what we saw on the Boxplots and the multi-vari. These are actually mean values with confidence intervals. And you can see, again, customer type 2 really rising to the top on average satisfaction score. And the fact that the confidence intervals don't overlap do tell you graphically that customer type 2 really does have a statistically significant higher mean satisfaction. That is also confirmed up here by this p-value. If the p is low, the null must go. Or in SigmaXL, if the p is red, you must reject. The null hypothesis is that all of the mean sat scores are equal, and we reject that. So clearly they are not equal, they're different. And this table here tells me who's different from who. So actually 1 and 2 have different means. However, 1 and 3 we cannot say are different. But 2 and 3 we can say are different. Okay, so that's the means matrix table tells you who's different from who, and the p-value tells you overall there is a difference. One last thing, R square is the percent variation in Y that is explained by X. Now that's saying 20% of the variation in satisfaction is being explained by customer type. That's actually a pretty low number. On an analysis like this, you tip it whether it's regression or ANOVA. You'd like to see an R square of 50% or higher. So there are other X factors that we are going to explore as well. Customer type is definitely significant, but there are other things that need to be looked at. To help us with that, one of the tools that we have is the scatter plot matrix. And I'm going to create a scatter plot matrix of all of the continuous variables. So again, I'll go to graphical tools and come down here to scatter plot matrix. And actually, let me take one step back here and show an individual scatter plot and then I'll do the scatter plot matrix. So scatter plots. And so we're going to look at overall satisfaction. Now, with a scatter plot, you need continuous predictor, not a discrete predictor. So I'm just going to put in average days order to delivery time, but I can also stratify, and I'm going to stratify by customer type. And then I'll click OK. And this produces 3 different scatter plots, 1 for each customer type. Now, I'm going to zoom over here to customer type 3 because this one is interesting. This is the equation, the best fit, least squares best fit, with an R-square value of 0.58. That's 58.5%. So that's actually a pretty strong association. Well, maybe not a strong association, but let's say a moderate association. And what it suggests is that if the average days order to delivery time are increased, customer satisfaction also increases. But you need to kind of take one step back and ask yourself, does that make sense? And the answer is, no, it doesn't make sense. You know, typically our customers will want things as soon as possible. You know, if we're FedEx, we're not going to use this as a model to tell us to delay our deliveries. So we, in a situation like this, sometimes you're going to see spurious correlations. Sometimes, for example, if you look at the relationship between umbrella sales and traffic accidents, you'll see a strong relationship. This doesn't mean that if people buy fewer umbrellas, there'll be fewer traffic accidents. So you can have, in this case, of course, that's a third variable, the weather, that links those two. Here, it's just a spurious correlation. There's, if you take random data and you look at scatter plots, once in a while you will see a spurious correlation. So you need to be careful when you're doing your analysis that just because there is a linear relationship doesn't necessarily mean it's a cause and effect, correlation versus causation. I think the statistics are very powerful and very useful, but they complement our business process knowledge, and the two work together. We don't chuck our knowledge at the door just because the graph suggested that if we're late, the customers are going to be happy. So we're going to continue our investigation looking at other potential factors, and I'm going to now look at the scatter plot matrix, which allows me to look at all of the continuous variables in one shot. So I'm going to include average number of orders, actually all of these variables. I'll just shift-click and select, and we'll go ahead and run the scatter plot matrix, which shows us everything versus everything else. Now there's a lot here. If I shrink it down to about 50%, you can see that there are a lot of graphs being produced. But the one that I'm really interested in is really the overall satisfaction. So I'm going to zoom in on that and scroll across. Okay, so here's overall satisfaction versus average number of orders per month. That's a very weak association. Just as a guideline, less than 50% is weak, 50 to 80% is moderate, and over 80% is strong when you're looking at R-square. This is that relationship that we looked at earlier. I'll just move these to make them easier to see here. R-square of 10.6%, but we already mentioned that that's really not a valid relationship. So we're going to continue our investigation here, and overall satisfaction versus loyalty. Now that one's interesting. First, I need to explain the quantized or the buckets of data are because the loyalty scores were retained as integer values. And so when you have something like that, then in this case the scatter plot will show up with just the the specific integer values for loyalty. An R-square of 44% is not really that high, and actually you would have expected a stronger relationship between overall satisfaction and loyalty. You know, maybe some customers are loyal but not satisfied, and other customers are satisfied but not loyal. And you need to, that would really be another project to understand why there is not a stronger relationship between the loyalty scores and the SAT scores. So I'm going to leave that one for now, but that's looking at the relationships on the Ys. Now, this one is interesting, overall satisfaction versus responsive to calls. We've got a nice R-square of 68%, and then overall satisfaction versus ease of communications is also a good moderate association. And these are two that make a lot of sense. Yeah, if we make it easy to communicate, if we're responsive to calls, then those should be drivers of customer satisfaction. So another one in the scatter plot matrix that we can look at is staff knowledge. And interestingly, there is no relationship between overall SAT and staff knowledge. Now, this doesn't mean that we can get sloppy on our staff knowledge. It just means that staff knowledge is not a driver of satisfaction. There are other things that are impacting SAT scores. It doesn't mean we can get sloppy and start hiring people off the street because the survey results showed staff knowledge is a weak predictor of satisfaction. But what this does help us do, it helps us to zero in on the responsive to calls and on the ease of communications. And the next tool that I'm going to show is multiple regression. And multiple regression, I'm going to put both responsive to calls and ease of communications into the model. So now SigmaXL statistical tools, come down here to regression, and I'll pick multiple regression. By the way, this is all in the workbook, so I'm moving rather quickly here, but these examples are all from the PDF workbook, and you can all go back and review those. Plus, this webinar is being recorded, so you can always download the recorded session. So on the multiple regression, now I'm going to look at overall SAT versus those two predictors, the responsive to calls and the ease of communication. I can also include categorical predictors, and in fact, I'm going to include customer type because customer type was earlier an indicator of a valid discrete predictor of overall satisfaction. So we'll go ahead and click OK and run that. Now on this report we have the a few things here. One is we can see from these low p-values that the responsive to calls and ease of communications are indeed statistically significant. Okay, the null hypothesis is that the factors are not significant, and so these low p-values tell you that both responsive to calls and ease of communications are important. However, customer type is unimportant. Now that's strange because earlier when we looked at the box plots, we saw customer type mattered. And here it's complicated, but it's the correlation between responsive to calls and ease of communications and customer type, and the fact that they're not independent. So when I model responsive to calls and ease of communications, in essence it swamps out customer type as an X factor. So really the key drivers are indeed responsive to calls and ease of communications. I'm going to do recall SigmaXL dialog. I'm going to rerun this analysis, and now all that remains are responsive to calls and ease of communications. Notice the R-square value is now 90%. So 90% of the variation in satisfaction is explained by these two predictors. So this is really important. We saw that visually with the scatter plots, and we confirm it with the multiple regression model, but we also confirm it with with process knowledge and going and looking at policies and procedures, and in particular customer type 2 in terms of the processes that are in place and the policies to respond quickly to phone calls and streamlining the process to make it easy to order. So you can validate by internally benchmarking and then developing best practices for developing your, for your solutions. Best practices can be benchmarked internally as well as externally. So in this case, our survey data validates the two important X factors, responsive to calls and ease of communications. So improvements are implemented, and one of the things that you want to always do is to demonstrate those improvements with data. And I have before and after data here, before improvement and after improvement. And what I will do is I will do a process capability analysis, just a quick process capability before and after, so you can visually see the histograms. So we'll put overall satisfaction by before after, and let me shrink that down so that we can see it more readily. Get that down more. Okay, so here, this was the before, and this is the after. So again, visually with the histograms, you get a nice, obvious improvement in the process. The other thing that we always want to do with before versus after data is to run a hypothesis test. And I'll go back to the before and after data, and we'll do a, under statistical tools, we have two sample comparison tests, very powerful. It allows us to compare everything that you want to know about your two groups. So I'm going to compare overall stat versus before after, and we'll run that. Now, there's a lot here. I'll be very brief, but basically what this is doing is it's testing for equality of variances, testing for equality of means, and testing for equality of medians. And before, I had a mean SAT score of 3.8. After, I had a mean SAT score of 4.2. Before, I had a standard dev of 0.8. After, I had a standard dev of 0.4. So it looks like, one, the mean SAT score has been increased and the variability has been reduced. So that's very important. We're not just interested in averages. We're also interested in reducing variation. Without getting into all the details, you just follow the yellow highlights. Because we have non-normal data, Levine's test is recommended, and this low p-value tells us that we have unequal variances. So the standard deviations, in fact, are different, and we have reduced the variability. This is also confirming that the means are different. So the fact that we have a low p-value here tells us that on the two sample t-test for means that indeed those means are different. There are two different formulas used, one that assumes equal variance, the other assumes unequal variance, and that is a cascade down from this test for equal variances, and the software automatically picks which is the appropriate test to use. So this is statistical validation. However, for presentation to management, it's always better to demonstrate things visually, and for that I will use the control chart on the before versus after. And so I'm going to create a control chart, an individual's control chart. Oh, and by the way, we have in SigmaXL a nice tool. There's a control chart selection tool that, depending on the kind of data you have and whether you have individuals or subgroups and so forth, that will take you right into the appropriate chart. In this case, we're going to use the individual's chart, so that's what I'll go in. And we'll use that data. I want to look at overall satisfaction. And I have advanced options, and in my advanced options, I can tell I want to split the control limits by before and after. So I'm going to go ahead and run that. So I clicked advanced options, before after as my historical group. And here's my control chart showing the before versus the after, and we can clearly see the reduced variation and the increase in mean, thus confirming that we really have improved our customer sat scores, and not only have we improved the mean, we've also reduced the variation. So that concludes my presentation, and I'll open it up to any questions.